Hello everybody, Tyler here, talking about Electron Affinity. Um, my partners were Dylan, Emmanuel, Jackie, and Maritza. They aren't with me right now because we recorded in a video earlier, but it got messed up, so I had to delete it and make a new one. They aren't here because it's 10:15 at night, and we are at my house. We are in my room, at the house that I live in. It's not my house, it's my parents' house. That's what they say. Electron affinity, let's get started. Electron affinity is the amount of energy being released when an electron is added to a neutral atom to form a negative ion. EA, abbreviation for electron affinity. Most atoms release energy when they acquire an electron, so an atom plus an electron yields into a negative charged atom with energy. On the other hand, some atoms must be forced to gain an electron by the addition of energy. So you have an atom plus an electron plus energy yields into a negatively charged atom. I drew a picture for both of those, even though there's a picture already on the slide. Okay, so we have an atom. Atom plus an electron yields into a negatively charged atom with energy. And that happens again when an atom acquires an electron, or releases energy, and when they acquire an electron. Alright, now I have this one, which is an atom plus energy plus atom plus an electron plus energy, which yields into a negatively charged atom. And again, that one happens when the atoms are forced to gain an electron by the addition of energy. Electron affinity is essentially the opposite of ionization energy. Instead of removing an electron from the element, we add an electron to the element to create an ion. Generally, the energy that results from this process, the electron affinity, is negative or close to zero. The more negative this energy is, the more this process is favored, which means the more this process happens. Here in this picture below, we have the elements placed on a graph, and these are all the different kinds of elements. The elements that are at zero, this is their electron affinity down here, and this is these atoms' electron affinity. So, yep. Among the elements of each period, the halogens gain electrons the fastest. The periodic table in the next slide shows the large negative values of halogens' electron affinities, and is a major reason for reactivity levels of group 17 elements. As electrons add to the same p sublevels of atoms with increasing nuclear charge. When electron affinities become more negative across each period within the p block. So, p block, you all know what the p block is. It just gets more negative as you go across the p block. And here's a picture of the periodic table and the elements with their electron affinity. See how you have some atoms at zero, like in the previous slide, how we had some electrons at zero and some were higher than others, like carbon is negative 126.3, but nitrogen next to it is 0. We can go back and show you. See how you have, what did I say, nitrogen at 0, and this right here at 126, it's about at 126, would be the carbon. So it goes from scale, or starts all the way from the first atom, which would be hydrogen, and is right here, and goes back down to 0, or up, I guess, to 0, to helium, and then so on and so on. So, and see, there's hydrogen at negative 75.4, then back up to 0, and there you go. So, nonmetals. When nonmetals gain electrons, the energy change is usually negative because they give off energy to form an anion, making the electron affinity will be a negative number. Nonmetals have a greater electron affinity than metals because their atomic structures, so the way the atom is set up. First, nonmetals have more valence electrons than metals do. Thus, it is easier for nonmetals to gain electrons to fulfill a stable octet. The valence electron shell is closer to the nucleus, so it is harder to pull an electron off, and it is easier to attract electrons from the other elements. Non-elements have higher electron affinity than metals. When an electron is added to a metal element, excuse me, energy is needed to gain that electron. Endothermic reaction. Metals have a less likely chance to gain electrons because it is easier to lose their valence electrons and form cations. It is easier to lose their valence electrons because metals' nucleus does not have a strong pull on their valence electrons. Thus, metals are known to have lower electron affinities. So, the outer shell of the atom is farther out from the nucleus, so the pull from the nucleus is not as strong as a nonmetal, which their outer shell, is closer, which the pull is stronger, so it is harder to keep their electrons. Endothermic reaction is a chemical reaction accompanied by the absorption of heat. So, when a metal uses an endothermic reaction, it's using absorption of heat. Noble gases, though already have 8 electrons in their outer shell, they already do, so they don't want to gain or lose an electron and become unstable or not a noble gas anymore. That is the end of the slideshow. However, I have found this video.
We've talked about the notion that it takes energy to remove an electron from an atom because that electron is attracted to the nucleus.
So that's how it happens. The electron is attracted to the nucleus, so it leaves the outer shell from that atom to go to the attraction that it has to the nucleus of the other atom to the outer shell, so it connects itself.